So before we get started with the technology architecture for both IoT and the adjacent disciplines, we can finish the remaining topics from yesterday's session, right? So we had kind of wrapped up on most of the topics in the healthcare IoT, except the one which I wanted to talk to you about, which is augmenting surgeries, right? So it's a very interesting use case. I'm going to run a short video for probably a couple of minutes. Take a look at this. Again, this is something in action. This is an interdisciplinary accomplishment, if you will, right? So there are a couple of companies which came together. Again, public information. I got an opportunity to play a small part in this. So we'll talk about this use case very shortly. So I'm going to run the video. Oops. Is the video not running? Okay, very good. Okay, we will leave it in this, I think. Actually, there isn't a voice in this, so I'm just going to cut out the voice. You could actually look at the text there. There are a couple of systems which have come up, right? Some which are continuing to evolve. So I got an opportunity to work with a couple of companies, right? One is Johnson & Johnson. The other one is Google, right? So Johnson & Johnson and Google partnered together to produce a concept called Verb Surgicals, right? So there is a company called Verb Surgicals. Verb Surgicals actually creates robotic arms, and these robotic arms are trained to perform surgeries, right? By surgeons, right? So there are videos of surgeries that are being done by the surgeons, and those videos are then taken. They are converted into keyframes. So as I was mentioning, it's an interdisciplinary approach. So there is a lot of artificial intelligence plus IoT involved in that, which is used to actually train the robotic arms, right? So I'm going to pause the video. This is only to give you an impression about what is happening in this field, right? So surgical robots are actually becoming a reality now. There are, as you would have seen in the video, Da Vinci is one of the world famous surgical robot, which has already performed a few surgeries, right? Like the gallbladder surgery and so on, right? Some of the relatively simpler surgeries, if you will. So they have already been performed by surgical robots. And multiple hospitals have begun using these. So this is a very interesting melting pot of multiple disciplines. There is a lot of IoT involved in this, multiple sensors involved in terms of looking at it visually, trying to understand the vital statistics of the patient as the surgery itself is performed, and the actual action of performing the surgery. So IoT and AI is coming together. So this is one example that we did not talk about yesterday in the area of healthcare IoT, right? Others, I think we briefly spoke about. We spoke about wearables, the automated insulin delivery systems. These have become commercially available, easy to use devices that are available over the counter. Of course, for the insulin, you will still need prescription, but the instrument can be easily bought over the counter from a lot of pharmacies. And patient adherence, we spoke about elderly care, right? So elderly care is like medical assistance for the senior people. And then the last one is patient adherence. We spoke about that also yesterday. So we'll complete the topic on healthcare here. We'll move on to the next one, which is consumer IoT. In consumer IoT, we are going to talk about probably like 2 or 3 things. Connected cars, we briefly spoke. I think you should search, all of you who are very keenly interested in the world of IoT, you should search for connected cars in YouTube. You will find a whole lot of videos that talk about what is the connected nature that they are mentioning, right? Whether when you start the car, you start getting information about how is the weather expected to be. Of course, today in all cars, you have integrated Google Maps that is already available. So map information is already integrated. Traffic information is integrated through satellite. You already have information about weather coming in a few cars. In addition to that, based on Google Maps, you also get some information about what are the different things which are available en route, right? And yesterday we spoke about Tesla. Tesla gives you information about what are the charging stations that are available, right? As you travel from one location to another, what are the different places where you could charge the car? So there is a lot of information that comes to the car, which is why it is called as a connected car, because it stays connected with the internet. It gives two-way. There is a two-way communication that happens. Car sends signals. Car also takes information from the internet. So that's the example of connected cars. I'm just going to do this one. Probably we'll play a very short video for like 1 minute or so. I think given the amount of time that we have to gain back, I'm going to keep all of these to only 1 or 2 minutes. Okay. So this is the next video.
Right about now, we're all getting pretty familiar with the idea of a connected car. You may already have one. But there's a brewing business model out there that is actually a bigger change than the sheer connectivity itself. Let's take a look. Most notably, it would be a car connected to the cloud via a built-in cellular data radio in the car or through an OBD2 port add-on device that has that cellular data ability.
So yesterday we spoke about this, right? So currently I drive a Honda City here, right? So the Honda City gives me an ability to connect to the internet through a SIM card, right? So there is a SIM card that we have bought. So it gives me maps, it gives me weather information, and through the app, the what do they call it? The Car Link app. The name of the app is Car Link. So using Car Link, I get a lot of information today, right? So it's connected through cellular again. It's a SIM card that we have to buy. So that's available here in India, which we drive now.
I mean, having a phone paired that can create a data link, but at that point, it does depend what apps you are running to meet the definition of connected car. I don't think something like streaming Pandora really counts. And I personally do not include a mobile hotspot in the car in the definition of connected car. That's just a hotspot. And that formula is rolling up to some big numbers.
So you got that right. So just because I have a cell phone when I am driving in the car, and if I declare a hotspot, that doesn't mean that the car is connected, right? So the car needs to have the ability to hook onto that, either go through the SIM card, or if the car actually connects to it through the hotspot, that's fine as well, right? But if the car has Wi-Fi, or meaning people who are sitting inside the car, if they have a mobile phone which has data connected, data plan in that, or having a hotspot, doesn't mean it is a connected car.
But huge numbers later, with a lot of cars times a lot of revenue and a very high growth rate, even though it's niche now. But here's the roadmap. Whether it's US or worldwide revenue you look at, billions now, with and that is that factory built-in cellular data radio. Let's say that adds a few $100s to the MSRP of the car. Looking forward, they're going to have 20 million cars worldwide with these radios built in by 20.
Please look up this video. I think there is a lot of advertisement messages mixed up with the technical details, so I'm not keen on this video. So offline, once the sessions are complete, you could probably go and search for connected cars. Many manufacturers, all the way from Ford, Audi, BMW, Mercedes, Honda, Toyota, all of these folks actually have a pretty good connected car today. The next thing that we spoke about, smart home, I'm going to not talk, because I think in the earlier example, we ran through the Samsung smart home. So all of you are aware about that. We'll take an example of telematics, right? So yesterday we spoke about this briefly, right? In the insurance premium world, based on your driver's pattern, there is a lot of information that is collected, as I told you, through the OBD2 port that was talked about in the connected car as well. So I will skip that also because we spoke about it. Next is the set-top box analytics. So set-top box, through which you are seeing cable television at your home today. that is another IoT device, right? So it has an ability to communicate to the central cloud facility your viewing patterns, right? When do you switch on the TV? What type of programs you watch? How long do you watch programs? In fact, the today's intelligence in set-top box can even detect whether the program is watched by a male or female, right? There is no video analytics there, but there are patterns, right? So the usual ones that you would have heard. A male, when a male watches a television, they do not actually hang on to one specific channel for a long time, right? So there is a shift in channels, etc., right? So there is a stereotype that they use to go and detect who's watching the channel. Same way, depending on prime time, right? So if it is between evening 6 p.m. to 8 p.m. or 7 p.m. to 9 p.m., what is the total number of people who are watching? So a lot of analytics happens there to gain marketing slots, right? So those slots are being sold through marketing channels for people to come and do the advertisements. Similarly, there is a maintenance also. See this example. Another short video which talks about what type of work gets done today on set-top box.
Hey everybody, and welcome to Tech Tuesday. I'm Rick Husey. I'll be right back.
So if you go on internet and search for set-top box analytics, you will find this. And I'm going to just play for only 1 minute and then we'll go back.
Thanks for joining me for Tech Tuesday. Today I'm going to be talking about some of the latest news with streaming. This is related to broadband, but also specifically to some streaming news that's out there. So why don't we get right to that? Got a lot to cover. So this was a big story. So AT&T has been trying to get rid of DirecTV, and this does relate to streaming, even though DirecTV obviously is a traditional pay TV provider. But
so worldwide, if you
they've got these three.
If some of you know what's happening worldwide with television these days, there is a significant reduction in TV streaming. People are going directly online. So a lot of TVs are getting shifted to smart TVs. So because of that, it's always a combination of people go and watch things on demand, right? When people go and watch content through Netflix or Amazon Prime or browse through YouTube or whatnot, right? So that is on one category, right? So the traditional programs that were actually aired through typical TV channels are all on the decline. There is more and more on-demand content, right? So content that people go and watch depending on their free time, right? So you don't have to necessarily rush for a 7 o'clock soap, right? A 7 o'clock serial, if you will, right? So people do not have to rush for that. So it's available on demand, depending on when they are available. So there is a lot of content to be collected or analytics to be performed on what happens or who is watching what at any given point in time, what is the total viewership, etc. Right? This is a pretty long video, but at your leisure, please go back and watch. You will know what is the kind of analytics that happens. So that's set-top box analytics. Yesterday, we briefly spoke about, I think, the smart shelves. This is one more example. Please see this. This is an example of how today's grocery store or a retail store functions. Why this video is not coming up? Please give me 1 second. This video should play. Yeah. So there is no sound here as well. So if you see, so there is showing a QR code to gain entry into the store actually, right? So it's a glass door, but there is a QR code. If you see here, as the person actually picks up different products, the shopping cart keeps on building here, right? So this is a complete e-store. Each shelf that you see here is a smart shelf. You may be able to observe some of the displays that are coming here on the smart shelf. So if you see Cheerios here, there are 3 packs of Cheerios. As somebody picks up, the inventory gets updated, the shopping cart gets updated. So he's actually picking up a drink, probably a Monster drink or whatever. So he has picked up 2 of those drinks. So accordingly, from in the store, the inventory will get updated and his shopping cart gets updated, right? So out of the 3 things, 1 is done. So if you notice here, in one of the examples, if he picks up the last one which are available, the smart shelf actually goes and places an order itself, right? So today's smart shelves are equipped to go and place an order if there are certain objects that actually run out of you are running out of those options, right? So that's what it does. So that is one example. And the other one that we completed, right? So again, personally, I was involved in this exercise, was to develop a mobile-based application using Siri, right? We're using iPhone's Siri and Android's Alexa, where we can ask a question, right? Saying, so if I am a pharma sales representative, I can ask a question saying, in the month of March, what was my sales for a certain drug, right? So if I have, let's say I'm selling paracetamol. So I could say, what is the sales for paracetamol in this month, right? Before I go to meet a doctor, I can get that information, or right in front of the doctor, I can ask a question to Siri, right? So and Siri will actually go back, run the query against a database, get that data. So like this, we had built around conversations around 170 plus key performance indicators for any business, right? So we did that for pharma. So that is another example of consumer IoT use case. The last one yesterday we spoke was smart library, right? So Bibliotheca is a complete library solution based on smart shelf, right? So and each shelf basically knows what is the weight it has. If on a certain shelf, if there are no books, then it will be able to say that there are no books here, or that specific category of books has been taken away by people. And when people come and return the book, it will automatically scan that and update it. So if I have taken like 10 books from a library, I return it back, then it automatically goes and updates it. So all of those capabilities are built here. So as I said, please go and take a look at it. It's the Bibliotheca is the name of the software. You can go and check out that on the internet. Okay. So that's all. So those are the examples of consumer IoT use cases. We'll stop there. I know it has been like 24 hours. Some of the content you may still have fresh in your mind. Some of them you may not. We will run one quick poll, basically to check what you have gained from the last two sessions. And then we will move on to today's session. Okay, I have poll here. And bring that back. Okay. So open poll. Please give me one moment while I'm setting up. So just as it is our usual practice, as I am bringing up the poll, if there are questions, please post on chat window. This is the last poll for the second session. I am going to start the poll again, a very short poll. I have 5 questions, 3 of them related to the subject, 2 of them to know from you, how do you feel about this session? I'm opening the poll. Please get started. Okay, so the poll is open. So again, today also I see nearly 100 people, 99 people on the 100 people on the line. So I would request you to request all of you to take the poll. So I see around 25% of the people have started. Please take others. Please take the poll. Okay. I see around 32% of people taking the poll. Can I request others also to take the poll, please? Nearly 60 people will have to start yet. So, David sir, offline you may want to ask a question to the participants in knowing if they have a challenge in taking the polls, right? Because in the last 2 sessions also, yes, I noticed that only 50% of people took the poll actually, right? Out of 100.
Mostly many people are using their mobile phones, sir. So it's difficult to switch over the windows and do something. That is also a challenge.
Oh, okay. I understand. Okay.
And particularly many of them are from northeastern states, so they
Okay.
have problems in connectivity also, sir.
Okay. Fine. So folks, who are actually joining from phones, I'm actually wondering, how you would take the last day's hands-on session. Maybe you may have to just observe. It's going to be a little boring to observe somebody else doing. I hope you guys are able to do it offline after that. Okay, so I see around 42% of people doing. So folks on I don't know if the poll window that I have, you are able to see. So I see around 45% people have taken. So I'll just give it probably one more minute to see if others are able to take. I would like to get as close to 50% at least as possible. So in the window, I also get information about the names of people who have not been able to start. I see in progress people. There are 5 of you who are still in progress. 45 completed already. It looks like some of you have logged in a couple of times. I see certain names being displayed twice. I do not know why. So it looks like there are some duplicates also. Okay. So I think we have had a good representative. So I'm going to close the poll. There are 8 of you who are taking it. Please do not worry. You don't have to rush. WebEx will take care of that. It will wait until you finish it. So please take your time. So I'm closing the poll now. Okay, thank you very much, folks. I'm going to display the poll results for you. We will also briefly discuss about that. So I hope all of you have the results on your screen. So industrial IoT focuses on, I think most of you have got the answer correct. All of the above, efficiency, productivity, safety are all the goals of industrial IoT, right? Most people are trying to improve the speed with which they are manufacturing, or they are trying to route it in case of logistics, or in case of automotive, they are trying to improve the efficiency or productivity and safety. We spoke about mining also. Second is healthcare IoT, all about wearables. I see a divided answer. So a lot of people have said yes, no. The answer is no. Healthcare IoT is not only about wearables. We saw some of the examples, right? So surgical robots is one example. There are cases where people are building mobile apps to improve patient adherence to therapy. So these are all other examples of healthcare. We actually saw 8 examples of healthcare, out of which only one of them is wearables. So healthcare IoT is much more broader than that. Then the next one, we asked, IoT field offers opportunities combining sensors, artificial intelligence, data, etc. So most of you have answered it correct. I see yes. I think only 3% answered no. So we actually spoke about this opportunity yesterday. We will talk about it in more details tomorrow. In fact, based on certain questions that have come up in the last couple of days, we are changing tomorrow's session to opportunities in IoT instead of talking about the connectedness. Then the last 2 things, I asked question about the session. Thanks, folks. There are a lot of you who have said that the session is informative, and you have an initial understanding of the opportunities that IoT presents. Those of you who answered no, please reach out to me. I will try to clarify as much as possible. Okay, I will share my my email address right at the end of the session. So I'm going to store this final. Okay, so I got the poll results as well. If there are questions on the chat window, I am going to quickly answer. Oh, okay, so there are others. Okay, there are others who have responded something, but it is not, there are no questions. Okay, so in which case we will close this session. So just a few seconds, I'm going to flash my email address in case people want to write to me asking any questions. I'm happy to answer the questions. Raju, R-A-J-U @neoware.ai. That's my email address. Feel free to write to me. So we'll move on with today's session. Okay. So today we are going to talk about architecture, right? So architecture for IoT and adjacent disciplines. So that's going to be the topic. So based on when we start, I think this is going to roughly run for a little over an hour. So, I would like you guys to be a little patient because it may extend beyond the time that we planned. So architecture topics, right? So in today's today's session, we are going to talk about 4 things. First is, what are the adjacent disciplines, right? Just like any other field, IoT also does not have an independent existence. So there are other disciplines or other technologies that are required for IoT to deliver some meaningful business outcomes or meaningful results for consumers. And the 3 adjacent disciplines are big data, analytics, and artificial intelligence. Most of the cases, right? It's not, well, an IoT device can function without these, but if you are using a combination of these, it can actually perform further analysis on that. It can crunch a lot of data that is being generated by the IoT device. It can be put to some use and it can deliver some value to the consumer or to the business. So that's why these are called adjacent disciplines, not the core disciplines itself. We'll also talk about block diagrams. So how does a block diagram look like, right? What are the 4 basic things that are present inside any IoT architecture? Then we will go a little more deeper and look at the detailed architecture diagram. Excuse me. And then we will pick up some architecture patterns, right? In the context of the 3 large cloud providers, right? AWS, Azure, and Google. These 3 vendors actually provide a very elaborate setup for developing IoT based applications. So we will see some architecture patterns, right, related to certain use cases. So we have seen applications or use cases yesterday and a little bit today. We also spoke throughout the sessions. We have also spoken about multiple use cases. We will pick up 1 or 2 of these use cases and see how their architecture pattern look like. So when you dig a little more deeper, right? So what are the adjacent disciplines? Primarily, you recall back the block diagram that we spoke about yesterday. You have the things. Those things or devices will have to connect. So there is communication, which was the second box. When they communicate with a central location, the data that they send out or the events that they send out will have to be captured and you have to store it somewhere, which is the cloud storage. And then there is processing, cloud storage and processing related to that, right? So once you store it, that information has to be processed either in the form of data engineering or in the form of performing analytics or AI, and you will send that information back to it. Some of this processing can also happen very near to the device itself, in which case it's called as edge computing. So those are the 4 blocks that we spoke about. So if you try to superimpose in that context, big data technologies are required for you to capture all the events and store it. And you need a significant amount of storage. So big data is an appropriate technique for you to capture and store. Second is cloud. As we spoke about, you need an ability to scale, because initially you may start off with 1 million devices. In a few weeks or in a few months, you will scale it up from 1 million devices to 1 billion devices. So you need a significant amount of scalability, and cloud offers a scalability. So that is an adjacent discipline. Third is analytics, because once the data comes, that data is stored, you'll have to perform some analysis on top of that to find out, is there anything interesting that is happening with the data, right? If there is data coming in from Apple Watch, it gives heartbeat information, or it gives you, pulse oximeter information every minute or so. Over a period of time, is there anything unique that is happening there? You have to perform that analytics. It may be an anomaly detection. It may be some, regression model that you built to find out something that is happening. And if there is anything interesting happening, there is an associated action. A similar thing, a logical extension to analytics is AI, right? And then communication, we spoke about multiple protocols exist for a certain IoT application. One of you could even become a communication engineer, right? In determining what type of communication protocol you use and what type of, and therefore what type of hardware has to be brought in, what type of software has to be built, etc. Finally, the security aspects, right? So we spoke about it yesterday. There are like concerns about privacy. There are concerns about data being encrypted, that people should not be able to attack a mobile application or an IoT application and get hold of vital information about people. So these 6 areas are the adjacent disciplines for IoT, right? So from an opportunities perspective, you can work or skill yourself in any of these areas. If some of you are interested in data crunching, you may want to go and learn Hadoop techniques, right? So you may want to go and learn Spark, right? Which is becoming a de facto standard for streaming, etc., right? So you may want to learn that. Some of you who want to deal with the infrastructure aspects of the IoT application, you may want to do a course in AWS or in Azure or in Google and become a certified cloud engineer from AWS, Google, or Microsoft. So that can be a good career opportunity, and so on, right? So for each of these areas, you could do that. So, so the 4 blocks that we talked about yesterday, right? Things and devices, edge. We will see what is included in this. Then you have data storage, processing, and platform. Then you also have the application, right? The application which actually brings that full functionality, right? Not just the data storage. So we spoke about it earlier, right? So some of you who may be into running may have seen an app like this, right? So Strava is an app, right? I want to just see if it is visible. You see here, this is an app that I use for my running. It's called as Strava, and Strava basically gives a lot of information. So there is an app. So the IoT, my phone acts as the IoT device here, right? So Strava is a cloud-based mobile application. So I download this mobile application from Apple's App Store or from Google's Play Store, right? So mine is an Apple. So I have downloaded it from App Store. So this gives me so the phone itself acts as the IoT device here. It gives me speed information. We spoke about multiple sensors. So it gives me cadence, it gives me heart rate, it gives me multiple things from here, right? So if I pick up any run, so it's been a while since I ran. I think it's more than a week. So the last time I ran was around 5 kilometers, right? So, or let's pick up this. So there is a run that I did like nearly 10 days ago. So 10.3 kilometers. So you see that. I hope you are able to see something on the screen. So, so this one gives information about, if you see here, it gives information for every kilometer, how long did I take. It gives me elevation information, which means there is an altimeter in this. It gives me splits, which means like, there is a pace meter associated with this, or a odometer, or I don't know what you call it, a speedometer equivalent, right? So it calculates how long did it take to run. So multiple sensors from the phone is being used to bring to that, and this is an app, right? So a complete app is required. So being a mobile app developer is also an opportunity in the context of IoT, right? So that's your overall block diagram. We go to the next level of detail. So I'll go bottom up, right? So the other day we spoke about sensors, right? Different types of sensors. It can be a simple sensor picking up only one type of information. It can be a complex assembly of multiple sensors, just like we talked about the phone. So an Android phone or an iPhone is actually a combination of multiple sensors. So it's a slightly more complicated device. There is always an associated firmware. So some software has to be delivered into the sensors for it to behave like that. Then there is an associated, so device hub or gateway takes care of the communication from the sensors to the cloud, or data coming in from the cloud to the sensor. So both by-way communication. Device management is about identifying multiple devices. So how does Strava as an application know how many people are the users, or how many mobile devices are associated with it? So it needs to be able to identify each of the mobiles, right? Like using the IMEI information, it has to uniquely identify every mobile. So there is an associated device management, and it has to install something there, right? So it has to communicate to the underlying layers of the sensors, so that those activities are taken care by the device management. Then we said about the data management and intelligence, which is when we looked at the 4 blocks, So the bottommost is the things and devices. Next is edge. Third is data storage, processing and platform, which is data management and intelligence here. And iPaaS, right? Platform as a service middleware. Then there are a set of APIs which are required. You cannot build every application from scratch because there are multiple versions. If you look at iPhone, there are multiple versions. You take Android, there are multiple manufacturers and each manufacturer has a different version. So you require an abstraction layer on top of the devices because each of them are going to use different kinds of chipsets. So we will see what type of chipsets are available. Each of them are going to use different types of chipsets. So you need an abstraction layer, and on top of that abstraction layer, you need a set of APIs to design and build your applications. So if you are, some of you who may be aware about the mobile development will know about Swift as an SDK for development for iOS. You have an Android development mechanism similarly to that. So which offers your APIs that are required for those development. And then using that, you do your mobile apps or mobile platform as a service, you do that. And for industry specific, there are certain types of devices, standards, techniques that you use for that, and websites, of course, which sits on top of this. So this is the overall granular architecture in which you operate, right? So, for example, when we built different kinds of IoT applications that I spoke about in the last 2 days, this is an interdisciplinary team, right? So when we recruit a team for developing one mobile application, when I say recruit, you pick and choose from your existing employee base. We need people, it depends on if we are going to build a mobile app, then I don't need people who can design sensors. I need to know which are the set of mobiles on which this can work. So I don't need hardware people with sensors. But if I am creating a completely new application, including hardware, then I need people with sensor background, with firmware and hardware background, right? So there are going to be a set of people that we are going to select and put there. You need some communication engineers who know what type of protocols to use. We spoke about that earlier. So you'll have to get one person like that. You need people who know what type of software has to be delivered to this. So I spoke about an example of MicroPython, right? So MicroPython is used to write code on a Raspberry Pi or an Arduino, right? So you can develop it using an IDE, an interactive development environment, and push the code down, right? So you need people with those skills wherever you have to interact at that level with the device. Then if that application involves a certain amount of analytics or artificial intelligence, then I need people who can write those models, right? People who can do anomaly detection, or people who can write a regression model or segment the data that is coming in. So I need people with that skills. I need people with big data. Then on top of that, I need people who know mobile application development, right? So iOS developers or Android developers, I require, people who can actually do the user interface design, UI, UX people, and then people who write code on iOS or on Android. So if you count the number of people that I said, there are at least 6 or 7 different skills required, right? People with sensors or hardware, communication, MicroPython, people who know AI type of techniques, or big data people, 5. Then you need mobile apps, and within mobile apps, you are writing native iOS or native Android, you need a couple of people there. So it's going to be at least around 7 to 10 people, and depending on the size of the application that you are writing, this can become a 20-30 member team with multiple people in each of these skills, right? So those are the type of skills that you will have to try and target if you are doing anything on IoT. So we'll try to do a double click on each of these layers, right? So we'll go at the bottommost layer first, right? So what are the tasks? So yesterday we spoke about sensors, and each of the sensors actually try to detect something, right? So they look at they measure the temperature or humidity or luminescence or sound decibels and so on, or multiple things. There are integrated tasks. These are some of the largest manufacturers of sensors and hardware for IoT related work, right? So Arduino, Raspberry are probably the most famous ones because they are also the cheapest. Intel Galileo is the other. Qualcomm does a lot of work when it comes to communication. So their focus is predominantly in the communication space. NVIDIA does a lot of work. NVIDIA, a lot of you may be aware because they are into graphics card manufacturing. They are the world's leader in terms of graphics card, but they also develop a lot of chipset. So if you see here, Qualcomm does the entire chipset also. So this is on the complete integrated circuitry. They give multiple chips, right? They are again their sweet spot or their niche is in communication, but they also do a lot of others. So you find Intel Galileo. Intel also gives a chipset like this. Marvell is the other one. Ayla is the other. Electric Imp. So there are multiple companies like this who give you, the integrated chipset, including individual components, right? So some of these only manufacture individual components. So when we recommended to you for Friday, we picked up one of these, right? So the Raspberry Pi is a very economic chipset with which we can try to experiment. So we gave that. There are more complicated ones that you would be able to buy on AWS, or you go to a local electronic store, you will be able to find those as well, right? So these are some of the players, and many of these people have presence in India also, right? So Intel, I'm sure you would be aware, Intel has a large presence here in Bangalore. Qualcomm has a presence. I think NVIDIA and Electric Imp also have a presence in India. So many of these people are present in India. So you should be able to go to their websites and find out what type of work they do, and if you are able to look for any job opportunities from there, you should be able to do that. So that's the first layer, which is sensors. Next layer is your device hub or gateway and device management. So yesterday we spoke about it in lot more detail, right? On what are the different types of protocols that are available. How do you choose a certain type of protocol depending on the bandwidth with which you will have to, or the bandwidth requirement in terms of how big your payloads are, the range of communication, the power needs that you have, the cost of this. So you look at least these four factors or characteristics before you choose the type of protocol that you require. But once you choose the protocol, there is also code that goes behind that in terms of connecting them. So if you were to take BLE, right, Bluetooth low energy, then we know that that's a short range communication. So you will have to write some code that operates within that protocol and so on, right? And you also need to look at, so this is an area where you need to have a really high fault tolerance, right? Which means your mean time between failure cannot be of the order of days or weeks. It has to definitely run into several months and years, if you will, right? Because many of these devices have a longer life, so you need to have highly fault tolerant communication mechanisms. And this is the layer in which you have to put the security as well, because if you look at the endpoints, the devices themselves will be secure, right? You will not be able to connect to it other than the ports that they are opening. Similarly, on the other side, when the data comes into the cloud, AWS or Microsoft or Google provides a lot of mechanisms for you to go and strengthen your security. You can put a perimeter security by creating a VPN. You can try to encrypt the data when it is sitting inside a bucket storage like S3 or sitting inside a database. We spoke about AES 256 as one of the encryption mechanisms that you can use. So a lot of security mechanisms, and you have multi-factor authentication to know who is actually coming in, etc. Right? So there are a lot of mechanisms available at the source and at the target. But en route, the communication is has to be secure as well. So we spoke about the TLS as a transport security protocol. So most of these devices will be TLS compliant. So you'll have to encrypt the data in flight so that in the target, they can deliver it in a decrypted fashion, etc. So security is a very critical thing for this layer. So both fault tolerance and security are going to be critical for this layer. So we looked at devices or things at the bottommost layer. Next layer is device hub or gateway for communication purposes, and device management for delivering software or interacting with the component below. The third layer is the data management and intelligence. So we spoke about that briefly. So there is a very basic diagram here, right? Let's go back to the earlier diagram a little bit and then come back. So if you recall this, okay, I think it was yesterday's deck. So let's imagine this, right? Let's say there is an IoT device sitting inside this room. So you have the sensors, and the sensor actually communicates to a cloud, right? I will have some application or code that is sitting in, let's say, AWS. So the data gets transmitted by the sensor to that cloud, right? And then once the data is communicated, there has to be some component which receives the data, which is the data stream collector, right? Which actually receives both event data and the sensor data, right? So if I have a data set, if I have a recipient which actually gets temperature data, not only it's going to get temperature data, it is also going to get some event from that temperature sensor. It will do some self-test to check its own health, right? So every few minutes or every few hours, it will send some signal which will indicate that that device itself is in a good state, right? It is not overheating or it is not going through some low voltage, and because of which its functionality may be compromised. So that event data will also have to be received by this data stream collector. Once the data is received, it will actually split into two parts. One, it will go and store a copy of that in a data storage. But that data will also be acted upon immediately by a real-time streams processor. The data is flowing. Imagine the data to be similar to a river that is flowing. So there are things that you do when you collect that data, collect that river in a dam. There are things that you do as the river water moves, right? So real-time streaming is like that. As the data moves through your line, you still need to go and check the data to make sure that there are certain things which are happening there. Right? If there are issues or if you detect something anomalous, then you will have to act on it. So yesterday we spoke about the IoT solution that we had developed in conjunction with Microsoft and GoSafe, where we'll have to communicate to the emergency response team, right? The fire engine, the police department, and the healthcare department, or the doctors and ambulances. So in those cases, right, as the data is flowing, you need to check for certain signals. If those signals are true, then it means then some event is happening and you'll have to immediately act. Which is why one copy is stored, and even before storing it, it is being acted upon. Then on top of that, you perform analytics, you perform AI, you apply some AI model, etc. At the end of it, you take that processed data and create some dashboards, right? So do some reports and so on, and say that how many events have come up, when was the last time this device failed, or when was there a surge in this. So I will give you this example, right? So one of the projects that we built, I think we did not talk about it earlier. It's called it was for a company called Thermo Fisher. Thermo Fisher is a biotechnology company which manufactures, among other things, they also manufacture what are called ultra low temperature freezers. So these freezers actually store specimen at minus 80 degrees Celsius, right? So it has to be frozen and kept there. And these specimens are like examples, like, if we go through a certain test, it could be a biopsy, right? A biopsy, which means there is a small portion of your tissue that is taken, or they may be operating on certain organism, right? So they would like to freeze it and keep it. So even a variance of 2 degrees, instead of minus 80 degrees, if it becomes minus 78 degrees, which means it has become warmer by 2 more degrees, it is not good for it, meaning you lose the specimen. The specimen is very important. So we implemented a model for them to look at the temperature of the ultra low temperature freezers. And these freezers are intelligent freezers. So they will keep communicating every couple of seconds. They will keep sending out at least 6 or 7 different data points. So we always look at those data points. So through the real-time streams processor, the moment you see something like 78 degrees or 75 degrees, there will be an alarm. It will send out an SMS. It will send out an alarm. So all of those things will be there. But there will also be consolidated information. On a weekly basis, you will look at all the 10,000 ULT freezers. How many of them worked properly? How many of them failed? So that is the consolidated information where you build dashboards, reports, and you give APIs for other applications to consume them. I'll pause there. I know it has been a flurry of things that we spoke about. I will pause for a couple of minutes for you to digest, and if there are any questions, we will ask. I'll take this. Okay. Prannivel is asking a question. Introduction of IoT to healthcare may lead personalized medicine, but doctors advise not to take medicine without consulting them. What are your suggestions and opinions? Yes. See, just like every other field, the field of medicine or care, right, where you have providers and payers, they are also going through a huge upheaval, if you will, right? So it's accelerated by two things. One is all these developments which are happening in IoT, in AI, the cheaper hardware, storage, everything is actually speeding up the entire thing, right? So the possibilities have become really enormous now. But having said that, there are two things here, right? One, is it indeed possible for an AI-based solution to come and actually diagnose? Let's say I am coughing today. Let's say I have fever and cough. Can an AI-based system actually diagnose and tell, based on some vital statistics or even doing some investigation, can it actually come back and say whether I am COVID-19 likely to have COVID-19 or not? Today's AI technology, for certain areas it can do, for certain areas it still has to rely on human intelligence, because the number of signals that human beings can process is like far outweighs today's compute capability also, right? Which is why we are still far off from what is called as singularity, right? Like I don't know how many of you here have seen the movie I, Robot. I, Robot is a very interesting sci-fi movie, right? So where it talks about robots which actually become aware, self-aware, and they all start acting together just like human beings act together, and they go and try to take control of the world. So we are very far away from that. At least another 30 years away, right? 2050 is when it is predicted that we will have singularity, which is a little scary today. But now what is happening is you can actually predict the disease. There is a possibility. I'll take a few minutes to explain that. I see a question from Balaji also related to that. You can, but the advice of doctors is absolutely critical, because today we cannot put our trust on people, right? Trust on people. Today I don't think people are ready to put their trust on machines. So this classic question is there, right? A lot of you may have known about the autonomous cars or the driverless cars, right? So Google has already done something, Tesla has done, Uber has already experimented with a driverless car in Dallas. But here is a question, right? As a technocrat, I may try to take a ride in that for a few minutes. But if instead of asking that question, if they say, can you put your son in that car? I will hesitate, right? Because I don't think that technology is sufficiently tested yet, right? There are questions like that. Similar to that with a doctor, a lot of governments or a lot of countries today put the accountability or responsibility of recommendation of, or when you see the typical doctor's step is like this, right? They take vital statistics, they look at you and try to do a diagnosis. To do the diagnosis, they are trying to do an investigation on you, right? An investigation will include putting a stethoscope, a physical examination. They may look at investigative reports, right, which could include a blood test and an ultrasound or an X-ray, MRI, etc. After doing all these things, they arrive at a final diagnosis. And for the diagnosis, they give you a prescription. And that prescription contains a regimen saying these are the things that you will have to do. This accountability will have to be with the doctor, right? Because if something goes wrong, then who do I go to? You can't punish a machine. You can't punish a program. If something is done in a deliberate manner, if there is a negligence and things like that, you still need somebody to be held accountable. So that is one part of it, right? Which is governance. But there is an ethical aspect to it. There is a capability aspect to it, right? Can an AI or an IoT, combination of IoT plus AI, can it actually replace a doctor with 30 years of experience, right? You cannot present all the types of scenarios that they have looked at, right? So it is going to be a challenge. So you cannot do that, right? So there are areas. So if you forget about AI, but coming back to the question. So first question to Balaji, the current state of technology maturity, you cannot do away with doctors, right? You have to go to doctors. And I don't know at what point in time, just like a lot of things are becoming augmented, I don't know at what point in time you will have a well-augmented doctor, a treatment administration. Coming to the question from Balaji, like how to predict the disease using AI technology. Forget about AI. We actually developed an iPad-based outpatient software for doctors, right? So where they will keep doing this, right? So there will be a front desk person who will take your registration information. They will take your family history. They will also take the vital statistics when you go to the doctor. So they'll take the temperature, the blood pressure, height, weight, and all of those things. And then they will ask you, what is the complaint that you have come here for? Have you visited any other doctor? Have you performed any investigation? So you'll take all of those things there. At that point in time, the typical Pareto principle applies. So when you look at a certain type of combination, like the example I gave for COVID, you can look at the 5 symptoms which are there for COVID, and then the software can say that there is a 60% chance that this person has COVID, right? So that prediction of what is the condition that you have, you can actually do for a lot of things, but that has to be accepted, and that has to be then told by a doctor, right? Even in India, or even if you take a few other countries like US or European Union, an AI model cannot come and do the diagnosis and give you a prescription. It can be done by AI, but a doctor has to take that and own the responsibility for that and give you that. That's the state we are in. So Balaji's question. So next is Pragya had asked a question: how can set-top detect if a viewer is male or female? Right. So there is a lot of behavioral science behind that on how people move between channels, what type of channels people are watching. So there is even some of it may look like a little funny, but the speed at which channel movement happens, etc., is used as one indicator to go and detect who's the viewer, right? It's not so there are no cameras attached there to a set-top box, so it's not looking at you to apply an object detection algorithm to say whether this is a male or female. It's done through behavioral pattern analysis. And then Balaji had asked a follow-up question: is there any possibility to hack the automated car? Of course, if there is a software, there is, right? So it's like, I think people are trying to resolve it like the first law of robotics, right? So when people write code to enable robots, the first law is always you cannot cause any harm to human beings or life. So similar to that, you can actually write laws where the moment you detect a hack, it has to stop, it has to go to the nearest safe place or whatever be that. So people are trying to resolve using that. It can be hacked. Any place where there is software, where there is a security built, it's always a constant tug of war, right? It is a race between the good guys and the bad guys. So if somebody is trying to hack, there is going to be a point in time where they can break. So there is also a follow-up question, guys. I'm going to take these 2 follow-up questions. After that, I'll try to answer towards the end. I don't want to monopolize the conversation with a handful of 3 or 4 of you guys. I appreciate the fact that you are engaged, but I will keep moving on. Okay. So do you agree that IoT can do a significant role in producing precision medicine? Yes, of course. There is no doubts about that. Actually, yes, it can. Because see, look at it this way, right? We always talk about one specific simple use case, right? For a diabetic, right, whether it is type 1 or type 2, you cannot recommend steroids. But we know, right, a lot of you guys may have seen doctors, right? So I know of a pediatrician in TRICHY. He's a very famous pediatrician, a fantastic guy. And there are days where there are really 250 people who turn up. So the guy actually starts at 7:30 or 8 a.m. in the morning. And God knows when he can stop that day. And he works 6.5 days a week, right? So it is always likely that at some point in time, somebody overlooks certain data points, right? And that is what a machine will not do, right? A machine will do it in a well set way. If you say, consider A, B, C, D, E, and say what is F, it will do that, right? Without tiredness kicking in or without overlooking something, it can do. So as far as precision medicine is concerned, yes, IoT can definitely do that, which is why you also see a lot of application of IoT on surgical arms, right? So in fact, in the example that we said, the surgical arm actually has a better reach than even a human arm, right? Because it can get into certain corners, because a surgeon cannot bend his or her arm in a certain way, but you can actually design a surgical arm with three connects, and it can go to unreachable corners. So there is precision with which you can deliver care. So that's the last one I'm going to take, which is from Ravi. Some fields are coinciding with IoT, like big data analytics, data science. It is not possible to learn everything. So how can we manage to learn these domains? Yes, that is why I said, it's a multidisciplinary work, right? No one person can actually do all of these things, right? So you have to choose one or two of these areas. In an experimental way, if we are actually trying to do a simple development, one can actually do, right? One can actually pick up a sensor. So for example, I was telling, right? So we can show, we have a, in the home system, right? So we are looking at light sensors, we are looking at, object detection, how many people are here. And based on that, you can control the AC to say, if there are 5 people, then if the room is going to get heated up, so reduce the temperature by like 2 degrees. So basic things like that you could do, like, it can be done by one person. There is not like what you said, there is no big data and analytics there. You just have to detect the number of people. You can actually pick up an algorithm from Microsoft. Microsoft has object detection algorithm based on which you can actually see, if you link it to a camera, you can find out how many people are sitting inside a room. So those are basic things that can be done. But the moment you go into real world industrial applications, one person cannot do all of these things. So you will have to choose one role and sit there, right? You may have to say that I'm going to play a role only in the sensors area or in the data and analytics area. So you have to choose one of these areas and stay there. So we answered a good number of questions. We'll move on. So this is the last section for today, but a long section. Reference architectures. It's a little crowded diagram on the screen, but once we start talking, it will become a little easier. So the ones which you see on the left-hand side are your devices, right? So you have many IoT devices. So you have Raspberry Pi, which is listed here. There can be many of the chipsets that are being produced by a lot of people. So they actually generate the events and data. So they are on the producer side. Once that is done, as we said, through one of the communication protocols, whether it is MQTT or BLE or 4G and whatnot, HTTP, it is going to communicate or send out that events and the data. And on the receipt side, so the way you should see is, up to this point, it is in the world, in the real world. After this, it is all in, okay, I shouldn't say real world, it's in the field. After this, it is all in the cloud, right? So everything to the right of this vertical line is on the cloud. So I've tried to put together this diagram which talks about Azure, which is Microsoft, AWS, and Google. If you use you can use any of these. You can also use completely open source IoT architecture, right? So open source components, using that you can build an IoT application. So if you look at Azure as an example, Event Hubs is that component which actually receives data in real time and performs analytics on that. Kinesis Streaming is an equivalent component from AWS. Google's PubSub is an equivalent component. So these three actually offer the same functionality. NiFi, a combination of NiFi plus Spark streaming in the open source world does the same. Or NiFi, MiniFi or Spark streaming does a similar set of work. Once the data comes, you have to perform analytics on top of that, which is where you have Stream Analytics from Microsoft Azure. Kinesis Analytics is the component from AWS. Cloud Data Flow is the component from Google. Once you process it, you are going to store it at rest. So you need a database or a file system. In case of again, I'm giving one example here. There are many technologies for each of these. So if you take data storage, if I'm storing the data, if you take a Raspberry Pi and I connect a sensor, you will see on Friday, we will connect a Bluetooth sensor or a temperature sensor. The temperature sensor will actually give a JSON file. And that JSON file can be stored as it is into a Azure Cosmos DB. Or in AWS, there is a DynamoDB. DynamoDB is a NoSQL database in which you will store it. Or you store it in BigQuery. S3 is a bucket storage. It's like a file system. I'm using an alibi for it. An S3 is a bucket storage, and a bucket storage is an object store, right? Similar to that, in Azure, you have Azure Blob, which is a blob storage, or an object storage. So you come and store the data there, and then for the final analytics, you will do the analytics using Power BI or Amazon's QuickSight, or from Google perspective, you use a Data Studio, right? So Data Studio does the reporting for you. You look at the open source side. You can use Cassandra. Cassandra is another NoSQL store, very similar to Cosmos DB or DynamoDB. BigQuery is not completely a NoSQL store. It's a relational store. So you have to do some pre-processing before that. So you have Cassandra, HDFS is a file system, Elasticsearch is a search-based system, Druid is another storage mechanism, HBase is another NoSQL store. Kibana is a dashboarding technique. D3.js is another dashboarding technique. Some of these components you may be aware, right? So you basically require these set of components to receive the data, to perform real-time analytics, to store it, to perform trending or creating dashboard, etc. You use one of these components. So you stitch so many components together to create a IoT based application or something which is a combination of IoT and analytics. Okay, we'll do one more deeper dive by looking at each of these. I have these links. When I send you the presentations, you will see the links from here. You can actually go into AWS, Azure, and Google. There are multiple examples they have given. Like if you are doing it for smart homes, how does it look like? If you are doing it for a mobile app, how does it look like? So for different things, they have given it. So I will pause there. I saw some questions which have come up. Before going to the next level of detail, we will answer those. Okay. So there was a question which says, is there any possibility of without any doctor's instruction using, I think it is a robo inpatient operation? Yes, I will come to that. How IoT will help in solving emerging environmental problem, pollution, polluted water, etc. Why should we use open source cloud infrastructure, not using Azure or Google product? Okay. We will answer all three of them before we move forward. Okay. We'll go in the reverse direction. See, open source is free software. Okay. So you don't need to pay anybody anything. But open source is also developed by the community, right? So you and I are going to develop or contribute to it whenever we have free time. It's not like an enterprise where somebody is running to a target, right? So for example, we are developing a lot of products. Some part of those products we are also open sourcing, right? We are contributing to the open source world. But I have a sales team. The sales team has a target, and that sales team will say that by Q2 of this year, I want to make $10 million. And that gives a drive for my product engineering team to develop things faster. So just because it is free, open source itself will not give you all possible capabilities, right? Obviously, AWS, Microsoft, and Google are all very advanced. They are putting millions of dollars and paying people to create software. Some of these softwares are going to have more features than what is available in open source. So all those things are there, right? So for example, Elasticsearch is an open source component. There is one company which has taken Elasticsearch and they are giving it in a commercial way. So you see Hadoop, right? HDFS is there, HBase is there. So some of you may be aware about Cloudera, Hortonworks, Mapr. These are companies which actually now Cloudera and Hortonworks have merged. Mapr has become defunct. But Cloudera and Hortonworks have merged and they use a commercial version of Hadoop distribution. Not just the Apache Foundation open source distribution. They give a distribution. It is similar to the Linux world, right? There is open source Linux. Ubuntu is available, right? But there is also Red Hat, which is a commercial version. It's a similar scenario. So you will go to such people like Azure or Microsoft Azure or AWS or Google because you would want something which is more, right? So which has more capabilities. Yes, you can learn any of these. There is no need to move from Azure to AWS. Once you learn one cloud technologies, one technology, the other technologies are going to be fairly similar. So if somebody is learning Azure, you don't need to move from Azure to AWS. Obviously, AWS is the leader when it comes to cloud. That doesn't mean that you have to learn only that, right? Azure offers a lot of free stuff. So as students, you should try to use what are the free things that Azure gives. Use that to learn, right? Once you know that, you can always read on the internet and find out what is an equivalent component. I told you, right? Like stream analytics, Kinesis analytics is an equivalent component. So use that to learn. That's all. So the next question was, how will IoT help in solving emerging environmental problems? Arkadeep. So Arkadeep had asked that question. See, we spoke about this, right? In fact, New York, the city of New York actually had a project where they had a lot of pigeons, right? So they actually tied IoT devices to pigeons, and the IoT devices actually had both carbon dioxide sensor and it had a miniature GPS So they will know, for example, a set of pigeons, if they are flying around Times Square, by the hour of the day, you can find out what is the level of pollution there, right? You could actually put a sensor in each of these places, but the advantage with the pigeons is that they keep moving around and you don't have to pay for the mobility, right? You don't have to put the sensor on a car and ask somebody to drive around or put it on a drone, etc., right? So, so there are projects like that where government organizations are trying to understand the level of pollution. But see, pollution is again a very sensitive topic. It also involves a lot of personal opinions. I don't think detecting whether there is pollution or not is the problem. The problem is about acting on it, right? So IoT or any technology can only take you so far. After that, you have to act on it, right? We all know that, this is like, I keep giving this example, right? A lot of us know that yoga is good for us, right? There is knowledge. We have already found out, right? So we have already detected that yoga or exercising is good for our health. But how many of us do it? We don't act on it, right? So there is only 10 or 15% of the population which indeed exercises or performs yoga or hitting the gym, whatever be that, right? So the knowing acting gap is always there. A device or an IoT or this technology can only help you in knowing or detecting, but then after that, acting on it is left to us. So last question, is there a possibility without any doctor's instruction or robot? Yeah. So we spoke about that, right? So I gave this example of verb. See, at the time of teaching or at the time of training the robo, you need a lot of data coming in from surgeons. So as an example, there was this project where people took gallbladder surgery as one example. So they took hundreds of thousands of videos of surgeons performing gallbladder surgery. They took that, they reverse engineered and worked backwards and looked at the various kinds of movements that are possible. When is an incision being performed? What type of medical surgical equipment was used? When was a scalpel used? When was what used? I don't know all the names, but all of those things were taken, and that information was used to train the robotic arm. So basic things even today robotic arms can do. But back to the ethical question or the accountability question, generally, robotic surgeries are not being performed without a human intervention or not without a doctor's involvement. So a doctor always controls it. Technically, is it possible? We are getting there. There are basic things that are being that the technology can do. But I think we spoke about it on day one, right? This is an overall ecosystem. Lot of things have to go together. There is technology, there are legal aspects, there are privacy concerns from citizens, there are worries and social aspects. So I have to be worried about what I can let my son go through or my daughter go through. So all of these things have to go together. Technology exists to some extent. Okay, so we answered a few questions. So I'm going to pick up this side. This is an example. Later on, you can go. So this is an example of connected restaurants, right? If for connected restaurant, what is the reference architecture from AWS? Right? So this is public information. I have just gone into. So if you see the link here, I'm on AWS's website. If you go to AWS's website, you will find this, right? So I will show you this example itself. You actually just go and search for reference architecture, IoT reference architecture. That's all you have to search. So when you search, where is my? So you just go and search for AWS. So see here. So I'm sitting on AWS solutions reference architecture. I have chosen IoT. You will see a list of different types of IoT based solution. What type of reference architectures are there? You can look at the type of components that are required. So in this example, I pick up connected restaurants. I'm going to make it bigger. If you see here, in the restaurant, what are all the things there, right? Free RTOS is the real-time OS, right? So based on those, there are a lot of devices. So they have given some examples here: thermostats, utilities, light bulbs, and cameras. So there are some devices in kitchen, some devices in the restroom, some devices in the dining area, some devices in the point of sale where the bill is being paid, etc. And there are drive-through restaurants, right, where you just go and drive with your car, stop at the window, place an order. I don't think there are many drive-through restaurants here in India, but you go outside of India, there are a lot of drive-through restaurants. You just go and place an order, right? So you go through a queue. Initially, you place an order, and then you go to the next window, you pay, and in the third window, you pick up your stuff and you leave, right? So there are devices in all of these places, right? So how do those devices communicate? AWS itself gives a component called IoT Greengrass core. There is a Lambda architecture. So all of these things. So you go and position some of these components inside the restaurant itself. So they provide these are hardware components. Some of these are software components. So you go and install these hardware software components on the restaurant, and these devices actually interact with it. In some cases, the devices itself come with an MQTT broker itself, right? So you will use that. And then this box is the AWS cloud on which you have given or stood up a lot of components. So look at the number of components they provide. AWS gives something called AWS IoT core, which has a device defender, which is a security mechanism. It has a device management. These are work that you do, right? So you create rules or you develop rules using IoT core components. You define topics, right? So under the hood, there is a component called Kafka. Kafka is a queuing system where, so how do you detect? So thermostat sends one JSON file that has the temperature. Light bulb sends some things, and it says that this is the luminescence that which I am in, or the camera sends something. So each of these are different payloads, and you detect what is a temperature information, what is a sound information, light information, etc. by defining different topics in your queue. So that's what you do on IoT core. And then we spoke about Kinesis data streaming. You use Kinesis to do real-time analytics. Kinesis Firehose is a component through which you send large volumes of data at one go. So it belongs to the same family of Kinesis, but Firehose, just as the name suggests, so the difference between when you open water from a tap and when you open from a fire hose, right, from the hose attached to the fire engine, it's going to just give a lot of data, a lot of water, similar to that. So we spoke about DynamoDB and Redshift, which are your database components. Then you have the API gateway, where you go and define your APIs for other communications, other applications to consume. You have AppSync from AWS, Amazon Pinpoint to locate and send information to specific dashboards, etc. For data processing, we spoke about, okay, we did not talk about, again, Amazon itself has like some thousands of components. Similarly, Google has, Microsoft has. So Glue is like a data processing engine, like it's like an ETL tool. EMR is Elastic MapReduce, which is just like your Hadoop instance. It's a Spark. You can make it as a Spark engine, HDFS engine, and so on. So a lot of components here, right? So if you have to actually have a connected restaurant and provide a lot of, so go back and read about this, right? So you will know there is a case study associated with this also. One example is KFC, right? I think KFC and McDonald's are here in India, so a lot of us would know about them. So KFC is a quick serve restaurant. McDonald's, KFC, all of these, they belong to a category called quick serve, meaning you go and quickly buy something, eat and come out, or you go through drive-through and get done and come out. So there, the turnaround time is very important, right? One example, long time ago, and I say long time, like nearly 3 years ago, we implemented something for KFC where they wanted to actually keep the turnaround time in less than 180 seconds. So when a car drives in, they place the order, they go and pay in the next window, and then they go and pick up. The time between when they order and when they pick up has to be less than 180 seconds, which is 3 minutes. Within that, you have to order, they have to make, just as soon as they order, it has to go to somebody to make, it has to go to the next window to collect the payment from you. So you are literally moving people from one place to another. And before that entire process of ordering, paying, and you drive to the next window and stand there, the 3 minutes is over and you don't get a feeling of waiting at all, right? So that's what people are trying to do. So if you have to do those things, then so many technology components are involved. So go and look at it, read through this. I have two similar reference architecture for Azure and Google here. So I'm going to just pick up one. I'm just going to flash that, right? So go to Microsoft Azure, just like I showed you in AWS. Here also you have a reference architecture for different things. So this is a generic reference architecture. So you have sensors. We spoke about OBD2 port, which is the telematics for a car. So this is taken an example of vehicle, right? So if you see processing real-time vehicle data using IoT, right? So that is the use case. So for each of those use cases, the reference architecture is different. So you have a GPS here. Your ingesting device management is here. So similar to AWS, if you notice here, Azure also gives a component that you keep inside the vehicle or inside a restaurant. Microsoft gives that. Then you do the analysis and transformation dashboard. The architecture is very similar. The components are different. You had DynamoDB there, you have Cosmos DB. DynamoDB and Cosmos DB are NoSQL databases. You had Redshift there, you have Azure SQL here. Both of them are relational databases. So here they have put Synapse, but Synapse is like a combination. There you had S3, here you will have Azure Blob. So there are equivalent components in each of these. So back to your original question, Ravi, you don't have to necessarily move from one to another. You can learn from one and you can apply to others. A similar architecture exists for Google also. I will quickly flash that and then we will take questions. So if you see here, so you see the 4 different categories for remote monitoring, IoT, MQTT bridge, smart home devices, cloud. What happens? So you look at remote monitoring. There is a reference architecture here. So I'll go back. So I'll go to Cloud Edge ML as an example. See here. So it gives a different thing. So it actually, so this edge, we spoke about it very briefly. I think there are certain topics that we could still not cover. I think, tomorrow when we spoke about opportunities, we will still leave behind a lot of topics that I cannot even introduce because the field has become so broad and deep that it's very difficult to touch on all topics within a 5-day window. So edge computing, we briefly mentioned though, right? So where you perform analytics at the very close to the device itself, right? You have to do that. Then you have to push the model. So if you see here in Google, the data may be sitting in BigQuery. You take the data and using their cloud machine learning component, you develop a model. You package that model using their compute engine. You register it through a container registry, and then you push it through through a TensorFlow, right? From TensorFlow, you have the trained model and you expose it as an API, and that has to be delivered into your actuators, right? So it goes and sits inside your device itself. So you can perform edge computing there. So for that, they have given a reference architecture, right? So for each of these, there are reference architectures. Some of these may look a little overwhelming, but if you start with the simple use cases, I can guarantee you that in a period of 2 to 3 months, you will be able to address a lot of these complex things, right? So it does look overwhelming initially though. So I'll pause there, okay? So again, another deluge of information that I have given you. We will take 5 minutes to answer some questions and then we will finish with the poll for today's session, okay? So any questions, guys, please go ahead and tell me. So as of now, I do not see any questions on the chat window. Any questions from participants? Okay, I think in the last reference architecture section, I think I dumped a huge amount of information for you. Yeah. Sorry, guys. Unfortunately, the nature of the topic is such. We'll go into the cloud, into the poll. This is the last poll for the day. Open poll questions. This one I already saved. So this is the session 3 poll. So I'm launching the poll. Just like earlier, please go ahead and take a few minutes to answer this. Again, very simple. It's not going to take anything more than, see, this one will not take more than 1 or 2 minutes. Okay. There are only 5 questions here. So please answer those quickly. So I see around 25 people already answering. 28. Good. Let's see if this time we beat the usual number of 50. So usually we see 50. So this time I'm seeing at least the 35 people in less than 30 seconds. So I will remain hopeful. 33. So meanwhile, if folks who are okay, there are like 2 or 3 people who have completed. So if people who have completed have any questions, please post them on chat. I will pick up those questions and answer. If you want me to keep quiet for 2 minutes, I will. So it looks like we lost some 6 or 7 people on the way as we were doing this session. Like 6 or 7 people actually got dropped off from the webinar. We'll give 30 seconds more. Sir, David, sir, tomorrow's session is like it's 1.5 hours or 1.25 hours. Can you please?
I'll just quickly check. So same timing, sir, 11:45 to 1:15.
Okay, so we have 1.5 hours. So
Yes.
okay, so okay, I'll give you a quick update about what we are going to do tomorrow.
Yes.
So we have roughly 40 people who have answered the poll. I'm going to give 30 seconds more for people who have not answered so far to do. If not, we'll close. 30 seconds more, folks. Okay, there are like 5 or 6 people who are answering. I am closing it. You will still be able to complete it. Do not worry. Okay. So I'm showing the poll results to you folks. You should be able to see now. So quickly we will answer those. Which of the following are adjacent disciplines to IoT? It's the first one. Almost everybody has answered except like 2 or 3 folks or like who have said C programming or management information systems. No, those are not the right answers. Cloud, data, and AI are the adjacent disciplines or the top adjacent disciplines. What are the programs written on to chips called firmware? Surprisingly, more people have said software. It is software, that is right, but a subcategory of that more called firmware because you are delivering it to the chips. Which of these manufacture hardware or chipset for IoT? Raspberry, Arduino, Qualcomm, Airbus. It's a multiple answer question, so there are like 3 or 4 people who have said Airbus, but all others have said Raspberry, Arduino, and Qualcomm. All 3 of them do that. We saw that. Which component of Azure does real-time analytics on streaming data? Stream analytics, a lot of people have said that, but I still see like 2 or 3 people saying Azure Blob or Cosmos or Azure Synapse. Those are not the right ones. Stream analytics is the right answer. Which of these components are used for dashboarding in open source technology? Some have said Spark streaming. Okay, actually, Kibana has been said by very less number of people. So I think I have not communicated that clearly. So Kibana is the component that is used for dashboarding in the open source stack. Actually, when you have the deck with you, you may be able to remember this more. So we will do that. So I'm going to save this poll. I would like the poll results. Meanwhile, if there are any questions, can you please go ahead and ask them on the chat window. Session 3 results. So I have got the results now. Does anybody have any questions? Okay. So one person has said, yeah, I think, Showman, I think there are recordings that have been done. So David sir, if you can actually inform participants, so some of them have missed prior sessions. If you could actually point them to where they could get it, they would like to see that. And
Yes,
Showman,
communicate, sir.
okay.
We'll communicate to them.
Sure. And Showman, anyways, I am going to give today's presentation also to David sir. So he will actually distribute all the 3 presentations to all participants.
Yes.
Okay. And before that, there was one question. Oh, okay. Thank you very much, Jaya Lakshmi. And Shivani had asked a question. Could you explain the last question? I'm thinking she is talking about the poll. Is that right? Let me see what was the last question.
She has responded on the box.
Okay. Yes. Yeah. Yes. The last question is Kibana, right? So I was mentioning that in the reference architecture, as you keep, okay, let me go back to that for a moment. I will show the shared screen. If you recall this diagram, let me go into slide mode so you're able to see it clearly. So if you notice here, after the data is fetched, right? So this is where the data is received between Spark and Spark streaming. This is where analytics happens. This is where data gets stored. And then after storing, you are going to do historical analysis, right? Like last 1 week, last 1 month, whatever data has come, you are going to crunch that data and produce some dashboard or reports, which is like, it's not like in flight. It's not like real-time analytics, but it is historical analytics. So for such analytics, when you are showing the dashboards, you use the component called Kibana. Just like you use Power BI, Amazon QuickSight, and Data Studio or Data Labs. So Data Studio and Data Labs are 2 components from Google. Amazon QuickSight is from Amazon. Power BI is from Azure. Similarly, Kibana and D3 are 2 components from the open source world using which you create dashboards. So that was the 4th question. I hope that clarifies for you.